The equator?
No, hurricanes never form at the equator. Never cross the equator, never form at the equator.
Come apart before that.
Yeah, that's more complex, but yes. I got a couple other little ones in here that you might want to think about, especially depending on what classes you've already had. For example, the main precipitation process in the tropics is the warm rain process, not the Bergeron process. You guys in the intro might have remembered the Bergeron process. You had to have ice crystals and super cold water droplet. Well, you know, it's warm through a huge deep layer of the atmosphere. You're not going to get that going on in the tropics. Okay, but that's kind of the detail of it. You got cloud physics or you got physical meteorology or something. Oh, okay, that's enough physical differences. Let's talk about the differences in the way we observe. Now, starting on Friday, we're actually going to have 2 or 3 days of lectures about observing the tropics, different observing systems, different observing strategies. But just to kind of loosely thin out here some reasons as to why we need to have a second course about we need to have a separate course about tropical meteorology because of differences in which we observe the tropics. Okay, we already mentioned the mostly ocean thing. It's really, really hard to have a radar station over the ocean. I don't know if you've ever thought about that, but you know, a radar beam, if it gets shot out there over the horizon, what's the typical angle, you know, the radar is shining out over the horizon? How high above the horizon is the radar beam? Like a ½ degree or something like that? Okay. You know, the radar's not looking up like that, he's like basically looking straight to this way. Okay. How are you going to do that at sea, like on a boat or something, or on a buoy, where the ship is tipping and stuff like that? How would you ever keep the radar beam pointing in the direction you wanted it to be, right? Actually, it can be done. Like during research experiments, they can go out there and they have these complicated systems of servos that keep tipping the radar so it stays level as the ship rocks. Okay, way too much work. We don't do that in general. Even the places that are land, we're going to euphemistically say that they are mostly developing countries. Just for the fun, let's look at today's tropical chart. In case you didn't know, there is such a thing as the tropical chart. They are normally out there in the mountain, but I actually printed these off the internet because we don't have any maps today. Here's today's tropical chart. I should outline the continents here. Here's Africa. Oops, that's my paper cut out. Here's Africa. Here's Saudi Arabia. Here's India. Here's Australia. Let's look and see who's sending in reports today. Not so good in Congo, not so good in whatever one's south of Congo, not so good in Chad, although we actually have one or two. Looks like it's pretty quiet today in Niger. Oops, sorry, that's off the edge of the screen there. Yeah, they're not reporting. Let's go look over here. Here's South America. Here's Central America. Here's West Africa. Let's see, Mali, not even a one that report. Senegal, maybe one in Dakar. Let's see here. Colombia, we got one observation there. Why aren't they sending in reports? DNA Christmas, we got more reports in the Omaha area than some of these whole countries have. Why not? Money, yeah, money probably. I mean, let's face it, Mali in sub-Saharan West Africa is not exactly made of money. Okay? It's just not a priority to their country. Now, by the way, that's kind of a generalism. Many tropical countries, even some very, very poor countries, are fabulous at taking observations, okay? Let's see here real quick. Let's find an example. It's right there on the team. It only shows one observation in Benin right now, but that's just because they can't get them all in there. Benin is great. Man, they send in like 30 reports in a tiny little country. And I don't know why Benin got so excited about meteorology. On the other hand, Nigeria sends in currently one. I don't know. Different countries have different strategies. There's also, by the way, lots of unfriendly, shall we say, countries in the tropics who just don't send in their observations because they're mad at the world. Okay, you know, go look for some good Iranian observations sometime. They're just not there. Okay. Nigeria, by the way, is that way too. They have. I've actually known several Nigerian people at the Nigerian National Weather Service. They have great weather service, they just don't send their reports to anybody. I don't know what they're doing with their application. Anyway, Western interest in tropical meteorology has mostly been for wartime needs. meteorology was done in the late 60s, early 70s. If you were a tropical meteorologist at that time, you needed research funding. There was no problem getting it. Why do you suppose? Vietnam, right? Okay? If you were doing Southeast Asian meteorology research and it just happened that they'd flare up a little war there, you know, you're in luck, right? The government will pay money for that, right? But what do you suppose, how much Vietnamese research is going on right now in Vietnamese meteorology? Right? Once we move on, we forget about these places, right? This is why I'm trying to make the United States to invade West Africa. I think I want to provoke a big battle with Burkina Faso. Anyway, we need troops there. This has got to be a golden age for like desert meteorology. That's all I got to say. Okay. Anyway, so wartime needs have been largely the West's focus on such things, and that just isn't necessarily good for long term in terms of understanding the processes we tend to forget. Because of the nature of the tropics being so scarcely observed, we tend to have a reliance on satellites. Now we're going to learn a lot about satellites and remote sensing in this class, and I think most of the people in this class have actually had the remote sensing course, so they probably know all kinds of interesting things about what you can do. This is more than just looking at satellite pictures and identifying clouds. We're talking about things here like retrieving profiles of temperature and moisture over locations using infrared and microwave channels and all this kind of stuff. It's a very, very elaborate business. Well, most of those satellites are either in geostationary orbits, which are partly over the equator. That's great for observing the tropics, right? Or they're in polar orbits, which doesn't mean they're over the poles, it means they cross the poles, but they're going over the tropics, you know, every 90 minutes or whatever. Both ways, these are actually relatively good ways to get observations of the tropics. On the other hand, you got all the problems with satellites. Satellite gets a little out of calibration. You need an astronaut out there with a wrench. Right? You got to figure out some way to fix this. And you got a reliance on things like buoys. We'll learn more about buoys probably on Friday. Buoys are a maintenance nightmare. Okay? They're out there in the middle of nowhere in a land of salt and bird poop. Okay? They are a maintenance nightmare. It's very difficult to keep buoys in any kind of working order. All right, what is the time? 10 after. We got 10 minutes to make it to this. This is perfect. Our third set of differences are in many ways more important, and this is the whole business of paradigm differences. Now, this used to be an easier thing to explain, because at one time the core at Creighton required that science students take a history class that was about history of science. Cool course. And a lot of what they learned about is paradigms. And so everybody came in this class knowing damn good well what paradigm was. They could give you a much better definition than I know and all this kind of thing. Well, unfortunately, the core changed, moved on, and we don't do that in our same way. I don't think anybody here took history of science. I think it's still offered, but nobody takes the core. Yeah, okay. What's a paradigm? Ken will know. Ken, what's a paradigm?
Actually, that's not so good. I'm sorry, I can't express what it is, other than it's more of a conceptual picture than the real thing.
Okay, I like picture. I like worldview. A paradigm, which I believe I got this from some definition from a textbook, is the current working concept. You don't need to know the definition of this stuff, but once you do it, you're going to be like, oh, I know what this is. I just didn't know there was a word for it. The current working concept that scientists use to describe their discipline. Okay, let us use an example. It is easiest to learn by example in this. Once upon a time, physicists believed in Newton. And F equals ma ruled the world, and everything that was important in the world was described in terms of Newton's laws. From the motions of the planets to me throwing this pen on the floor, to whatever, to springs, to whatever, it was all Newton. And then that pesky Einstein guy came along and found out that not only was Newton wrong about some things, like subatomic particles and motions of galaxies and stuff, he was in fact wrong about everything. F equals ma doesn't work for this pen. We don't say that in physics, by the way, that would learn all that crap. Right? Turns out it's wrong. Everything is about relativity.